Good morning, dear plasmatic friends. Today we're gonna add and subtract radicals. Follow me, please. First of all, we have to say that when we multiply or divide radicals, there is no problem. You can put everything into the same root and work exponents and many things. But when you are going to add or subtract radicals, you must search the same roots everywhere. And here it is not the same root. 48y, 12x squared y, and 75y cubed, it is not the same. So we are going to work to get the same roots, and after that we're going to simplify those expressions. Remember, I told you, when you have numbers into the roots, you have to factorize those numbers: 48, 12, and 75. Remember, to factorize it, you have to search if you can divide it by 2. Yes, because it is a pair number at the end. So 48 divided by 2, 24, and 24 divided by 2, 12, and divided by 2, 6, divided by 2, 3, and you cannot divide the 3 by 2, but you can divide it by 3, and it is 1. After that, 12 divided by 2, 6 divided by 2, 3, and the 3 can be divided by 3, 1. Finally, you cannot divide it by 2, but 7 plus 5, 12. So you can divide it by 3 because it is in the table of 3. 75 divided by 3, 25 divided by, not by 3, but by 5. 5 divided by 5, 1. So that is, we can write, instead of writing 48, I'm going to write, pay attention, if you have square root, it is very useful to write exponents of 2. And if you have cube roots, you should have exponents of 3. And if you had the 10th roots, you should find exponents of 10 to simplify those expressions very easy. So here I have 2 squared times 2 squared times 3. So 2 squared times 2 squared times 3y. Instead of writing 48, I write 2 squared times 2 squared times 3. Plus, instead of writing 12, I'm going to write 2 squared times 3 x squared y. Finally, instead of writing 75, I'm going to write 3 times 5 squared y cubed. But pay attention, wait a second. Y cubed, it is not very useful here. So I'm going to write y squared times y. And why? Because I need exponents with 2. Because I have here square root, square root, square root. So now I'm going to divide those roots in many parts in order to simplify very easy. So y times square root of 2 squared times square root of 2 squared times square root of 3 times square root of y plus square root of 2 squared times square root of 3 times square root of x squared times square root of y minus square root of 3 times square root of 5 squared times square root of y squared times square root of y. And why? Because you can say that if it is the square root of 2 squared, square root and the exponent will be finished, and you have the 2 outside of the root. Here it is the same, the square root with the 2 eliminated, the square root with the 2, the square root with the 2, the square root with the 2, the square root with the 2. So you have here y times 2 times 2, and square root of 3 and square root of y, you can write it into the same root. After that, the 2 is outside the root, the x outside the root, but the 3 and the y inside the root, because you cannot eliminate one exponent 1 with the square root. And finally, the 5 outside the root, the y outside the root, but the 3 and the y inside the same root. I can do that. So I'm going to erase those expressions, and 2 times 2, 4y, multiplying the square root of 3y plus 2x multiplying the square root of 3y minus 5y multiplying the square root of 3y. And I see that now I have the same root here, here, and here. 3y, 3y, 3y. This is very, very good, because we can get the common factor of the square root of 3y. Have one term separated by a positive sign of another term separated by a negative sign of another term. So the common factor will be the square root of 3y. And remember that when you are factoring expressions, you take the first term and you divide it by the common factor. The second term divided by the common factor, and the third term divided by the common factor. You open a parenthesis and you divide. 4y times the square root of 3y divided by the common factor, square root of 3y. And when you have the same, you can eliminate that, and it is 4y. The same for that. 2x times the square root of 3y divided by the square root of 3y. You eliminate the same roots and you have plus 2x. Finally, this divided by this, you have negative 5y. Finally, we can simplify it, because here you have 4y and negative 5y. So you write 2x minus y. And that's it. Because here we have like terms. When you add and subtract radicals, you have to find like terms. And here I have like terms. Remember, addition and subtraction of algebra. You can watch that video. Thank you very much, dear friends. See you next time.